Hello, Mahesh.
Hi, how are you?
Thank you for joining. Uh, I'll just introduce myself first, Mahesh, if you don't mind, and then I'll hand over
Please.
to you for a quick introduction. My name's Matthew Rutherford, or Matt Rutherford, and I work for a company called Evapco. We are a heat rejection equipment manufacturer, and we supply equipment to data centers for the removal of the heat from the data center. And by removal, I mean at the end of the line, when all that energy is extracted from the white space, we are the equipment on the roof generally or outside of the data center that expels that energy into the atmosphere. And as a manufacturer, we we produce all different types of heat rejection equipment, some of it 100% dry, so it doesn't use any water at all. And we produce adiabatic systems, hybrid systems, and we also produce evaporative systems, which are entirely reliant on the evaporation of water to remove the heat. And we work with lots of clients in determining what is the best solution for their particular project. And there is really no right or wrong answer to that question. All projects and clients are different. Some like using water, some are entirely dry. But one thing which is definitely a fact is that if you use water in your data center, you will consume less electricity. And I guess that is the core of what we're going to discuss today with Mahesh, is getting that balance between water consumption and energy efficiency. In other words, if you don't use water, you will be consuming more electricity. So where is that tipping point between one and the other? So I'll just hand over to you now, Mahesh, if you want to introduce yourself.
Yes, hi. Thank you, Matthew. Thanks to the team at Critical Insight to invite us today. It's a wonderful conversation to be part of. My name is Mahesh Ramanujam, as you see on the screen. I'm the president and CEO of Global Network for Zero, world's premier net zero certification body. We are focused on energy, emissions, water, and waste. And our goal is to provide certifications across the building sector, the businesses, products, and whatever needs to be decarbonized around the world. So that's our focus area. Broad scope we are playing in, but we play a very focused area in terms of being able to do certifications. And prior to Global Network for Zero, I was also the president and CEO of US Green Building Council and chairman of GRESB, the ESG benchmark for real estate. So it's exciting to be here today because my primary goal is to help validate the net zero implementation in the market and be able to articulate the nexus between energy and water emissions and energy waste and water and etc., so that we can raise visibility around how these cross-functional things should come together to be able to help deliver a meaningful decarbonization roadmap for our industry and eventually get to the 2050 goal. So great to be here with you, Matthew. So looking forward to this dialogue.
You. Thank you. And I know there were some questions in the previous session. I don't think you were present for that, so I think we'll probably get a few questions at the end as well. But just to move on from my previous point, Mahesh, in relation to the energy consumption of a data center and the balance between water and energy, and of course the carbon footprint as a result. When we do our analysis with end users and designers looking to design a data center facility, we are constantly evaluating different cooling technologies. And when we talk about the larger hyperscalers and the larger unit users, the reality is that the most of them are dry anyway. The vast majority of data centers are using air-cooled chillers, for example, to cool their data centers that don't use any water. It's only when there's an attempt to reduce the PUE of the data center or increase the efficiency of the data center that we start to have discussions about alternative cooling systems like dry coolers at one end of the spectrum and fully wet systems or open cooling towers at the other end of the spectrum. And as we move through that spectrum, from dry all the way to fully wet systems, you gradually obviously increase water consumption, but you massively reduce the power requirements to run that cooling system. And when you consider that a cooling system in a data center, so the chillers and the heat rejection equipment combined, are around 35 to 40% of the total power consumption of the facility. And when you compare the power consumption of a dry cooler heat rejection system compared to a fully evaporative heat rejection system, you can expect to reduce that power consumption by about 60%. So how do you find that? How do you obtain that balance between a very high efficiency cooling system that's using water but using around 60% less power with a system that's completely dry but not using any water?
Yeah, I think it's a very important to understand, just to level set the audience. You're given a very good perspective on why this is challenging, right? This is very challenging, but the opportunity exists for us to do. But to do a level set, I want to give a couple of points related to the water energy nexus, the one that you talked about. First things first, when we look at it, water use in data centers parallels energy use and carbon emissions. I think you touched on it already. And it's very important that we all understand that the three are deeply interconnected. So it's a balance, as you rightly pointed out. Then second, yes, you are absolutely right. Cooling is the biggest factor. Without cooling, the energy demand will go up. Now, for example, today data centers use millions of gallons of water a day to prevent overheating of processors. So it's a very critical ingredient that goes into basically keeping not only the data centers up and running, but making them resilient. Then obviously the AI workloads that we are seeing is only increasing, right? Day by day, you're seeing some massive announcements coming from particularly the US related to data center growth, and where AI is leading the way. And actually a University of California study recently estimated that every 100-word AI prompt consumes roughly 1 bottle of water, right? Just 1 bottle of water for every 100-word AI prompt. And we can see ourselves doing that AI prompt within like 2-3 minutes. So each one of us are easily consuming 1 bottle of water in no time. And if you multiply that by billions of users who are actually trying to use that by every day, even millions of users, the footprint becomes significant. Then Google also reported about a 14% increase in water use, primarily from cooling needs. Microsoft reported 42% of its global water consumption is coming from high water stress regions. And so much more is going on related to water. So we need water in data centers. But if you don't have water efficiency, like the way you pointed out, the 60% actually beats the second example that you gave. So to me, water is critical to keep the data centers running. Water efficient equipments are super critical because without water, the data centers cannot run. But if they can deliver energy efficiency as part of it, that is like double bonus for us. So absolutely, that is something that I feel that type of innovation that you articulated has to become the key theme, because we cannot just ignore water. And there's only limited supply of water available, because particularly if you're in a water stressed region, and it's something that you should really be careful about. So that's my perspective on that particular view that you shared.
Yeah, and that is interesting. And I've heard a lot of different variances on the amount of water that a simple search consumes in an AI portal, etc. And it does vary quite wildly. And my question would be to that is just in mind that not all data centers have evaporative or adiabatically cooled cooling systems. So most of them are dry. Uh, and that's a fact. So when we talk about data centers, there aren't these huge water guzzling contraptions on the roof consuming millions and millions of liters of water. The vast majority of them are using dry cooling systems anyway. It's just the ones that are striving perhaps to have the lowest energy consumption that are wet. And
Yes.
And when we talk about this teaspoon of water or this bottle of water that is being consumed, where is that actually being consumed? Is that an average over all of the data centers, or is perhaps it just further upstream? So when you look at this water consumption topography of a complete system in a holistic sense, are we talking about the energy consumption at the power plant, for example? So if we're consuming 1 kilowatt extra of energy at the data center, what's the net footprint in terms of water of that? Because you're now consuming more water, perhaps further upstream at the power plant.
I think it is the net usage is what we are trying to talk about, but I don't think there is a sufficient clarity because you bring up a good point. The 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 overall number is what we are trying to attribute to the data center. I think in fairness to the calculations, we should attribute that to the overarching end to end, right? Basically, starting from the power plant all the way to the consumption level. That is a better metric to track, and it is to highlight the point that energy, while we have put a lot of emphasis on energy, we have to also think about water being a very important ingredient that is needed for the data center. But if we can strive to deliver energy efficiency without actually use of water, that's ideal. And I think that's where the case for your particular solution, other things are made. So I think it's more the conversation is about the overarching holistic metric rather than a specific data center metric. I would imagine the data centric metric to be even more narrow and lesser, not more. But nevertheless, when you're thinking about emissions, we typically take into account the holistic view. That is how the compute works.
Yeah, yeah. So it's if we're talking then about water consumption, and we're saying to ourselves then, let's look at it holistically. Let's look at the water consumption all the way from the nuclear power plant on the hill, all the way into the data center. And if we accept that if you're not using water in the data center, then you're using more water at the power plants. How do you go about calculating that? Then you would use a metric to balance between the type of energy that's been the type of power plant, so whether it's gas or whether it's nuclear, and all of that would go into the equation.
Absolutely. I think that is why we always say to people that identifying the sources, understanding the specific emission factors that are associated with it. If you're trying to calculate emissions, and that theory flows into all other places, so you really have to do types of energy sources, the number of handoffs that are happening between location A to location B to location G, because we had to also attribute energy losses, energy distribution losses that's happening. And third is that where are you actually trying to pin down the efficiency requirement, right? Are you doing it at the data center level? Are you doing it at the community level? Are you doing it at the grid level? That mapping is very, very important. That is where it gets really complicated. And that's why we tend to pin the data center, because that's a consumer, ultimate consumer. So we tend to just drop it into that bucket. But ideally, the right way to measure will be is to understand the inventory of sources, understand their underlying emission factors, underlying the emission or the distribution related impacts, and then eventually come back full circle and calculate the actual impact. And that is something very, very hard to do, as you know very well, because there are multiple stakeholders. And there is also a challenge of double counting as well, because sometimes you're counting other people's emissions, which are emissions or usage in this case, and that makes it really difficult. But generally, that's the flow, and that's a method we prescribe.
Yeah. So is this more then when we talk about trying to reduce that reliance on water and the amount of water that a data center is consuming? We're only moving water around. We're not destroying the water. We're turning it into a vapor, and then it disappears off into the atmosphere, and I guess it precipitates somewhere else. It is consuming vast amounts of energy in the process, and thereby reducing the energy consumption. So when we talk about trying to reduce that water consumption, is this a local issue, and is it more related to the area that you're trying to build the data center in? Obviously, if you're next to a river, or if you're next to a very plentiful source of water, is there really any issue with using that water? Or is this more of a question then of not sustainability, but how reliant you are on that water source in general. Because if you have a data center that is cooled by cooling towers, if you lose that water supply, then you lose your cooling system in its entirety. You no longer have a cooling system. So is this more about resilience than sustainability in the main?
I think you hit the nail on the head there. The most important part is obviously the commonsensical thing for us to say is that if it is a water constrained area, then water becomes a very, very critical ingredient or a thing that you use. And if it is water surplus, then why bother? That would be a general tendency in which you would think about it. But the issue here is that should there be a situation where the water itself becomes a constraint, then the prioritization of that water will first go to the community, right? If you have a factory and that factory was consuming a lot of water, forget the data center for a minute. I'll give a generic example. The first option, if the residents don't get water, will be to allocate water to them first, and then the business will get. So it becomes a business risk issue. In this case, a data center risk issue, because that is compounded by if you have a cooling plant, if you have huge dependency of having water related cooling systems, if you use water to do it, then it becomes extremely difficult to run that data center. That's one scenario that's very easily possible because, in the world that we have operated in the last decade, we have seen enough surprises to know that never say never because something will disrupt you and you don't know what is going to disrupt you, right? That's number one. Number two, that generally there is an argument that's going on in the United States. There is a lot of pushback coming in related to the water table itself going down because of excess usage of water. That it could be because of data centers, that could be because of other factories around you, that could be because of other residential construction that's happening. So when you see this water constantly being not replenished properly, because the argument is not about consumption, the argument is about can you replenish it as much as you are taking it, right? And if you're able to strike that balance, which is what we are trying to do through our net zero water certification, is that can you achieve that balance? And if you're not achieving that balance, then conservation is the most important way. Always you must conserve, but it is also important to balance. That's the whole premise of this whole net zero. So when you look at it from that perspective, it becomes purely a business risk issue, and that business risk or a community risk issue, and that becomes a very, very important element for resiliency. It's not about sustainability, it's about resiliency. In my mind, resiliency is about bad things are going to happen, things are going to go out of control. Have you planned for it, right? Do you have that exigency planned and we are able to regulate in it? And that's what I think it is. And so regardless of whether you're in a water surplus region or whether you're in a water drained region, you still have an obligation to think about conservation and efficiency as a key construct. So absolutely, it's a resiliency issue, it's a business risk issue. And I'll give you an example, right? In Tennessee, it's completely the opposite example. In Tennessee, we had oversupply of water, we had flood, we had a massive flood, and the NCOA's data centers were jammed. The people who were to predict what the weather is going to be, they went underwater. That data center became inoperational. So it's not just about lack of water, but it's also oversupply of water has also caused a scenario. So that became a resiliency risk issue. So too much water zone is also bad. That's a scenario that doesn't fit here, but it happened. It happened in the last 6 months in the United States. So absolutely, it's a resiliency issue.
So is this about infrastructure then? And I know there's a lot of discussion about boosting the energy supply, building more power stations to satisfy these huge loads that are in data centers. But I don't hear a lot of talk about building more reservoirs, about building more boreholes. And we're obviously going to build more power plants. You move that power around in cables, which are, I guess, similar to pipes. Why can't we move water around as well in a similar sense, just to offset some of that additional load that might be in some of these power plants that we're trying to build? So is this, I guess, really, it's a risk assessment. It's a choice of how much am I going to spend to offset that risk or manage that risk. In other words, do I build several Olympic-sized swimming pools to store water to give me 24 or 48 hours of resilience? Do I spend a lot of money digging a borehole? Is my data facility critical infrastructure, so I'll still get my water if I want it, or is it not classed as critical infrastructure, therefore it's going to get switched off? Most of this is more complex than just that public perception of I don't want to use a teaspoon of water, or I don't want to use a bottle of water, but it's more about a risk assessment and a balance between OPEX and CAPEX.
Yeah, I think it is an infrastructure issue, right? Because we are building this AI infrastructure on one side, and we are going as fast as we can because every day we are expanding, right? Mega data centers are coming because it is solving a particular need. It's solving a very specific need, right? Our information needs, our business needs. You take an example that you like, and it's solving a need. Of course, energy is another ingredient needed to make those data centers work. And because we have so much focus on energy for the last, 5, 6 decades, we tend to think everything in energy terms. So we are thinking of power plants, we are thinking about energy infrastructure, we are thinking about energy efficiency, etc., etc. But you cannot say that the same level of emphasis has gone into water, to your point, right? Water is kind of like, it's taken for granted. We think that water is a finite supply. And yes, water is a finite supply, but the techniques, the investments, the planning that is needed to actually be able to provision for that water infrastructure has not been catching up to the same level as which the technology boom has happened, right? Particularly in this space. Now, the second part of the question is that where do we find the land? Now we get into a very complicated set of requirements that comes with it. One of the biggest challenges will come is that if you want to create a 4 size of swimming pools of Olympics, example, who is going to give you the land? Where are you going to provision it? Where is the water going to come from? How are you going to make sure the water supply flows from which part to where? And is that going into the community first versus you? All these complex issues come in. So there is definitely an element of infrastructure planning needed. But since such a plan doesn't exist, or it's evolving or has to evolve, the conservation becomes the obvious statement that everybody makes. The efficiency becomes the statement that everybody likes to make. But I do believe that there is an infrastructural component is needed to balance, or we have to come up with some super duper efficiency and innovation in equipment manufacturing where we can actually cool and conserve less energy. One or the other has to evolve, and that is a work in progress, in my opinion, based on what I have been studying on this topic and what I've been observing on this topic and all the discussions I have with the stakeholders.
Yeah. And what I've seen as well is that when data centers were a lot smaller, and they were a lot smaller, massively smaller, the conversation wasn't about, it was about water consumption, and it was about how much water am I going to use in a year. What does that look like from a cost perspective? What does that look like from a water treatment perspective? How much water am I going to need to store for 24 hours or 48 hours? Now what I'm finding is that conversation has evolved somewhat because the data facilities are so big. It's not necessarily how much water am I going to use in a year, it's how much am I going to use in a second. Literally, how many liters per second am I going to need to deliver to this data facility? So it's not just does the water exist, it's can we move it quickly enough to the data center facility to keep up with demand. So in certain instances, in particular cities, there might be, I don't know, a 10 liters per second or 20 liters per second limit, just how big, based on how big the pipe is going to the data centers. So it's not necessarily about the availability of the water, it's how quick you can actually physically deliver it as well. So that's a slight evolution of the discussion. But as data centers get bigger, densities are increasing. The amount of heat that we have to remove is outstripping the other elements of the formula, which might be fluid temperature, which might allow you ordinarily to use dry coolers because the fluid temperatures are increasing. The densities appear to be growing quicker than the fluid temperatures are elevating, which is meaning that if you need to fit more cooling equipment into a smaller space, then evaporative cooling or the use of water also allows that. So quite often it's not necessarily a question of energy efficiency. It's a necessity just to fit enough cooling or heat rejection in a certain footprint. And I think in Europe, that's more of a more of a relevance or more relevant because we are limited for space, more so than in the areas you've just been mentioning, like Tennessee or wherever that might be. Most of the cooling equipment that we produce or deliver in Europe tends to go on the roof. And when it
Mm.
goes on the roof, you have a limited amount of space. In North America, quite often it goes adjacent to the data center facility, more space, they can put it in a field next to the data center facility. That gives a different type of solution to what you might be able to consider in Europe as well. So I think geographically, and particularly in Europe, the question is a lot more complex in Europe than it is perhaps in North America, because if you're going to go dry, quite often you just don't have the space to do it. You need some element of water consumption, not because of an energy constraint, but because of a spatial constraint as well.
Yeah, actually, Matthew, that's a very good point. But I also want to give a little bit of a different perspective to it. In America, if you want to take the example of the US, the issue is permitting. So if you see a lot of data centers are facing significant challenges with permitting related to energy and also related to now I think water is also getting a lot of pushback because while you are constrained by space vertically, for lack of a better word, adjacently, horizontally, America is constrained because America's land permitting laws don't allow you to just permit land so that you can actually go out and consume them for a purpose, right? Particularly the usage determines. If it is for a community need, probably you'll get a permit faster. But if it is for a data centric related thing, I think there is some challenge, particularly on the energy side. We have seen it already. For example, renewable energy platforms could not be just activated just like that. There is definitely a challenge there. But to your point, Europe definitely faces more because there is not even a land available to even apply for a permit. So definitely US is kind of having a little bit of luxury of land, which Europe doesn't have. So it's an interesting contention point, right? To your point about that. And also, I think on the chat, I just read a question. It is important to clarify. We are all talking about freshwater supply, and that freshwater supply actually makes it even more challenging. This water conversion becomes even more challenging because the aptly pointed out by one of the attendees that the water has to be a freshwater supply for the data center, or the potable water is very, very important. So yeah, these challenges do exist, and these are infrastructure challenges, these are land challenges, and these are challenges that we have to really be cognizant of. It's not a simple linear solution. It's a very complicated infrastructure development solution and an opportunity.
Yeah, yeah. So, if you talk about Amsterdam, for example, no water at all. So there's just a blanket ban on water consumption in
Right.
Amsterdam, and
Right.
that's kind of a one size fits all solution to what's perceived to be a problem, but in of itself is perhaps creating other problems because no two projects are the same, and there may be instances where the lack of water, even a cup of water, is not permissible. That could solve other issues that are becoming known only once you start to try and build an infrastructure that is only 100% dry, so no water at all. So water is not just saving energy, it's also solving other issues as well. It's reducing instantaneous demand on the grid, for example. So again, as I spoke earlier about instantaneous water demand, there's also questions about instantaneous energy consumption as well. So again, it's not just a question of how much energy am I consuming annually. If you have a refrigeration system that has elevated fluid temperatures because you're dry, then you're consuming more electricity, and that's instantaneous draw off of the power supply. And when you consider for every 1 degree Celsius increase in water temperature, you're going to consume something in the region of around 3% more energy on your cooling plant. That's considerable, particularly when you're looking at 100% dry systems that may have peak fluid temperatures of 47 degrees versus something like 28 degrees Celsius for an evaporative system. So these are all elements. It's a complicated picture, and there's no right or wrong answer to it. So, and as I say, we as a company at Evapco, we have no particular axe to grind. We produce 100% dry systems all the way through to evaporative, but we find it very interesting because no two customers are the same as well. All customers have a very different approach or a different attitude to it. So it's been interesting to get your thoughts on that. I think I've just got one eye on the clock, and I can't actually see the questions myself. I'm not. Oh, Q&A. Is this it?
Yeah, the
Um,
Q. That's correct.
yeah.
That's the box here to go.
So do we go through this, or does Jordan pop up and ask these for us? But we can have a go ourselves.
I think we can go through it and just
Yeah.
give a perspective on it.
So does water need to be a potable water supply? I think we got asked that. That was asked previously. No, it doesn't. You can treat water. You can use desalination plants, and you can use seawater if you want to. You can use reverse osmosis systems. You can filter grey water. You can dig boreholes and treat the water, but it needs to be treated. So it doesn't need to be potable at source, but when it enters the system, it needs to be mainly softened, some of the hardness removed from the water. In some instances, some of the mineral content as well. Chloride levels in particular can be very problematic. So you do need to treat it, but it doesn't necessarily have to be potable water or tap water as such.
And also, I
Uh,
think it needs to be, if I may, Andrew, sorry, Matthew, I can ask this question just as a follow-up. It needs to be returned in the neutral state, right? If we are going to send the water back to the community or the water table,
yeah.
is that requirement to be just to be neutral?
Yeah. So um, I think that's an interesting question, and sometimes it depends where you're depositing it back into, such as if you're taking it from a river and you're returning it to a river, you have to be mindful about how much you're cycling up that initial content. So if you've got an incoming water supply and it has a certain mineral content, and then you're using that water or you're evaporating a certain element or a proportion of that water, you're concentrating up that mineral content in whatever's deposited back into the source. And in some instances, not in all instances, you have to be mindful that there are certain limits to what you can deposit back into certain areas. But in addition to that, when you're using water, there's other elements that need to be considered, which is predominantly hygiene. For example, in cooling towers, you need to use biocides to protect the people around the system from various things like Legionnaire's disease, etc. So you'd be using biocides to control that. And in doing so, obviously you're using man-made chemicals, you're injecting them into the water supply, and it's in what sort of concentrations are you doing that? And depending on the type of chemicals that you're using, is it how do you dispose of that? Does it become in effect an effluent drain or waste supply as opposed to something that could perhaps go to a wastewater drain like a storm drain? So there's other ways of treating water. So water treatment in of itself is a whole different discussion. But there's chemical free systems, ultraviolet lights, all sorts of things. So there's means to an end, but certainly disposing of the water is a critical part of the design process. Is how do you manage that, and what do you do with that water supply based on the quality and what's in the water when it goes to drain.
Got it. Thank you.
DCs are often fed by a potable water supply. Are there structural failings, the UK national water providers infrastructure, which leads to a lack of provision for non-potable water services? I assume less processing of water to potable standards would equate to more affordable water services if the infrastructure was in place for this. Yeah, so I mean, I guess simply water treatment costs money. Water treatment is expensive. The plant is expensive. You could do that in the facility, Obviously, it's better if the incoming water supply is pre-treated. But if there is a source of water and you could treat that locally within the data center facility, what that would come down to, again, is this balance between how much you're paying for that alternative water supply, do you need that alternative water supply, and effectively, what's the capital expenditure required to change that incoming water supply into something that you can actually use. I'm just mindful of the time here, Jordan. Just pop up and let us know if we're running out of time. There's a lot of questions.
You're absolutely fine. I'll let you get to you're the last session of the day, so I'll let you get to
Okay.
the end of the questions and then go from there.
All right. Okay, good. Yes, water precipitates elsewhere, but largely into a saltwater body. The concern is that DCs are utilizing the finite resources of freshwater supply. I feel that's important to clarify. That's correct. Yeah. So once you evaporate water, you've got no control where that's going to precipitate. And I think we touched on that as well. Or you touched on that, Mahesh. Is
Yes,
that
that's correct.
it's the infrastructure that we have to collect water when it actually does rain. And I know you're talking about water tables dropping, etc. Maybe it's just raining less. And as is pointed out there, perhaps it's just raining into the sea as opposed to on land. So that's something that you can't predict. And yes, for sure, certainly based on the current infrastructure in this country in particular, there is only a finite amount of water that is available, and therefore it is a precious resource, and we should look after it and only use it where it's absolutely necessary. If data centers are critical infrastructure as recently designated in the UK, well, that's interesting. Wouldn't DCs get priority usage of potable water over those not designated as critical infrastructure? And does domestic use get priority over this? I'll be honest with you, this is a topic that's come up a couple of times as part of the design process in some of the projects that we've been working on. And that has been a question that's been tabled to some of the water authorities as to who gets water when it's absolutely needed. And I'm not sure if all data centers are critical infrastructure or just some. I don't know whether it's if the data that they're actually processing is deemed as critical, that they would get any special treatment. But I don't know if there's a hierarchy in terms of what constitutes critical infrastructure, i.e. does a hospital get water before a data center does? And at what point do they turn off the domestic supply so that we can all keep watching Netflix? I don't know how that's calculated personally, but certainly it's a question for a lot of these data center operators is if you're reliant on water and it runs out, who gets priority? And is there a minimum volume that the water authority will guarantee at any one particular moment in time? That's not something I'm aware of. Mahesh, are you aware of that? Is that a topic of Mahesh? Is that a topic you've touched on in the past? Is priority of water supply?
That is a topic we are discussing, but I would say that I am still exploring the topic. So not that as detailed as you outlined, but that is something that we are kind of getting introduced in that concept, in that direction.
Okay, 10 new reservoirs are planned in UK over the next 10 years. I understand the question is whether this is enough and are they in the right place? Is a designated AI development zone. Okay, so yeah, I think that again is what we spoke about, isn't it? Where it's, we're all talking about building new power plants, but are we talking about actually building local reservoirs for water supplies to these data centers, if indeed they need water? Because as I said earlier, there's an awful lot of data centers that don't use any water at all. You're just going to have to build a bigger power plant to supply the energy to them. So it's that balancing act. Currently, the water companies have a mandated responsibility to supply domestic properties, but not businesses. Does the critical infrastructure designation supersede this choice for supply? Again, I'm not sure how if you had a choice to still get Netflix or be able to run a bath, I'm not sure how they come up with that particular make that decision. But And I'm not entirely sure if all data centers are deemed as critical infrastructure, i.e. if it's a government operated data facility or a medical facility, or if indeed it is just a streaming service, whether they would all be equally deemed as being critical infrastructure. I don't know, to be perfectly honest, and I'm not sure if there's a clear narrative on that, or even if if there's a variance between different water authorities.
I also think, Matthew, if I may comment on that, it is also a little bit of a political issue, because with the way the world is currently evolving towards on the political side, every single time, even a designated policy like that, clarity also would basically be a voter's choice or a citizen's choice. So that can also put a tilt, particularly to your earlier point about this being a localized issue, right? Everything is local. So sometimes it can get really political, which one takes priority depending upon your interest in winning an election or influencing an election. Those things also are something we should not downplay. It's such an important element of all these policies. But that is what we are saying in US. In the US, there is a variety of issues are happening, because one side AI boom is being encouraged, other side AI is being blocked by a variety of people. To an extent, it's a political issue.
Yeah. Stuart asks, pressure should be placed on the hyperscalers and developers to partner and provide water infrastructure for the processing of desalination of saltwater sources and direct use of fresh water, providing a route to purify. Yeah, that's a good. Yeah, you can desalinate seawater, and you could use titanium heat exchangers and titanium pumps and very expensive equipment. And I think what all this would come down to is where you're building your data center. Is it near the sea? That's why you build nuclear power plants next to the sea. I mean, it's because there's a large heat sink there right next door. So the same could be done with some of these very large data centers. I think that is the case, certainly in the Middle East. They're building them near the ocean. But it's expensive. Any water treatment is expensive. The treatment itself consumes more energy. And I think, again, this comes down to not necessarily just a question of doing the right thing. It's always a question of, well, how much is it going to cost as well? But yeah, for sure, you could desalinate seawater and use treated river water, and then perhaps the question about water and sustainability may go away slightly, but it's very expensive. Do you know how much water is used per kilowatt in power plants? I've heard the hydro sounds great, but evaporation from reservoirs is actually higher per kilowatt than cooling towers. Is that correct? I don't know. I have looked at it. I haven't. There was a white paper that was published recently, and we did look at that. And again, it comes down to this question: if you're saving a kilowatt in the data center, that's how much water does that equate to at the power source, at the source of the energy generation? And I don't know for sure. I think I'm not aware of an holistic study that's been done to that effect. Everything I normally look at when I do these studies is at very local, is in the data center. So it's how many liters of water am I evaporating per kilowatt of data and heat rejection that we have to manage. We don't zoom out and look at it that holistically as to how far down the further upstream the water consumption is increasing, because my energy consumption in the data center has just increased by 30%. I'm not aware. I haven't done that study. Mahesh, I'm not sure if I think you hinted that you do look at this much more holistically, and you do zoom out, you do pan out and look at this in a more holistic sense.
Yeah, I think the key construct is that, I don't know the specific wattage used per kilowatt hour, but the water evaporation that is happening at a reservoir level is at this point of time tracking very higher than data centers, right? Data centers are catching up quickly there, but data center, as you rightly pointed out, is a function of energy usage and everything else. But the evaporation loss and the water that's actually being lost in reservoirs is technically greater than data center. I can give that reference point. that larger studies, most of the studies point to that. But the idea here is to avoid that evaporation being compounded with further data center evaporation. So that's the right way to look at it. But in short, reservoir evaporation is higher. I don't know the specific number yet because we don't have a specific number in any studies yet, but it is higher than, and it is growing. Unfortunately, it is growing compared to other things, particularly because there is significant change in climate temperatures. Different locations who are never used to be hotter are getting even hotter, and then of course hotter climates are even getting hotter. So those type of things are contributing to it. So that is what we have tracked so far in our holistic studies.
Okay. Yeah, so I just quickly looked at there was a white paper published by Tech Buyer. You can probably find a link to that white paper via the Data Center Alliance webpage. And the document is called Drowning in Data. It looks at water consumption in a lot more detail. And there's a table in there that looks at the amount of water per kilowatt hour. And it does vary depending on what the power generation source is. Nuclear is somewhere between 1.5 to 2.5 liters per kilowatt hour. Natural gas, 0.5 liter to 1 liter. Coal is between 1.5 liter to 2 liters per kilowatt hour. Solar and wind is 0. So I guess if we're all running the country off of wind and solar power, then that's the problem goes away. But yeah, there are estimates on how much water is consumed per kilowatt hour within the power generation plant itself in that document. Yeah, so that's called Drowning in Data, and you could find that on the DCA data center web page.
Is that specific to any particular region, or is it general that is that stat based on what you read?
I'm not sure how much variance you get in the water efficiency of a nuclear power plant, but there is quite a lot of variance in there. So like 1.5 to 2 liters. There's quite a lot of variance there. So I'm guessing it's fairly similar from region to region. And as we migrate to different power sources, that topography is going to change, isn't it? So the interesting question would be, how does that kilowatt of energy in that water consumption compare to how much water I would use with an adiabatic cooler, the data center, to reduce that power consumption by 1 kilowatt? How similar is that? That's a discussion that we can probably have if somebody ever sits down and crunches the numbers. So I could probably look at that actually. But yeah, that's a very, very interesting question. So I think there's a few more questions keep coming. Does liquid cooling actually reduce a data center's water consumption, or does it only improve efficiency inside the data hall, while water use still depends on the external heat rejection system? If a data center continues to use evaporative cooling towers, does water use stay high even with liquid cooling, and does water use only drop when liquid cooling is paired with dry coolers? Yeah, so if you're using a dry cooler, there's no water consumption. But if you're using a dry cooler, then your efficiency in the data center of the equipment that you're liquid cooling is less efficient because the temperatures are higher. So efficiency is related to fluid temperature, not the liquid itself. Well, it is related to liquid, but closely related to fluid temperature or liquid temperature. And if you're using a cooling tower, you have lower liquid temperatures, which means your heat rejection is lower because you have less waste heat from the data center. And if you have a completely evaporative system, the amount of water that you consume is proportional to the heat load. So if the equipment in the data center is more efficient, if that's because it's liquid cooled and it's consuming less energy, that means you're going to consume, or you're going to need to evaporate less water within the cooling tower. But what we're seeing is that the demand for heat rejection is outstripping the increases in efficiency. So data centers just keep getting bigger and bigger and bigger, and the fluid temperatures aren't elevating as quickly as the densities are. So you can only reject a certain amount of heat per liter of water. You evaporate a liter of water, it consumes an amount of energy. So as your heat rejection loads go up, the amount of water you're going to consume is going to increase, let's say, almost proportionally for a like-for-like cooling system. So really, probably if you want to really start maintaining efficiency, keep the most efficient cooling equipment, but improve the efficiency of the equipment within the white space in the data center itself, therefore reducing the amount of heat that needs to be reduced, and therefore reducing the amount of water that needs to be evaporated. Thanks for that link to the white paper. It kind of suggests WE of 1 is still a benefit over nuclear. Okay, so it's like someone's found that white paper. It's a very interesting white paper. It's there's a lot of information that's gone into that from various sources. So yeah, I think that is a very good paper for anybody who's interested to seek out. Again, it's called Drowning in Data, and you should be able to find that on the DCA webpage. Okay, I think we're out of questions.
Amazing. Thank you, Matthew, and thank you, Mahesh. I will.
Very much.
I appreciate that you were over your time that you allotted to yourself. But I know it's a very meaty subject that sort of even the 50 minutes that we were here for, like, still, I could imagine you could speak for another few hours at least.
No, I don't. No, thank you. No, that's good. And thanks, Mahesh. That's very, very, very nice to meet you. It's the first time we've spoken, isn't it? So it was really good
Yes.
to meet you
Good to meet you.
and
Thank you
hear
so
your
much.
thoughts as well. Been a pleasure.
Yeah.
Amazing. Thank you both for that session, and I will now let you go.